We have a bunch of headlines. You know, why read all those things? I'm just going to tell you about them, so let's go forward. Oh, yes. Last year at this show, 1 year ago, I said the following. By comparison, 2016 doesn't have nearly the number of headlines that 2015 did. That's the risk of making a prognostication, because within 2 weeks, there was the announcement of the discovery or the suggestion of something that's referred to as Planet 9. Now, this is not Pluto, and it's not Planet X or Nibiru or anybody who's going to come kill us. It's an actual real live planet, according to the definition, about somewhere between about 10 times up to about 10 times the size of Earth, and way the heck out in the outer part of the solar system. First of all, here are the guys who were in the press a lot in January for having done it, Mike Brown and Konstantin Batygin. So the way they did it is really following up on some work from 2014 that recognized that there are a bunch of objects, sort of comet-like objects, small icy bodies in the outer solar system, that all share some properties of their orbits that suggest that something, you can sort of see there's sort of a common point of origin here, something flung them all out. And that something is now proposed to be this Planet 9. The Konstantin and Batygin and Brown did a more thorough development of that idea that was suggested in 2014, and now have made predictions about where we might be able to find it. So the hunt is on to find Planet 9. How fun is that for you to be living through? And moreover, they say that they're going to find it in the next 14 to 16 months. So their prediction is, and they're not finding it alone. There are teams, 2 dozen teams around the world looking for this thing, but a lot of work has been done on where we might find it. And so maybe next year we'll be telling you about the actual visual discovery of Planet 9, perhaps. We'll see. Or maybe it's not there and they're wrong, and then we all get to say, oh, Mike, you're wrong. And then 1 month later, one of the biggest headlines of all, the discovery of gravitational waves. Now, for those of you who don't know what I'm talking about, you can clearly see that something's jiggling. In fact, there are two measurements of something jiggling. And you might think, well, you know, what in the world is that? When you overlap them, they really look quite the same. But what those little jiggles are something absolutely fundamental to the nature of the universe, and in particular to the nature of space and time that pervades the universe. Just always my favorite picture of the universe is that one. The description of the universe and of space of time, you know, has evolved over time, but we more or less subscribe to and are guided by the principles that Einstein set out 101 years ago in relativity, and then in 1915 in general relativity, where he was wise enough to recognize that space is not just a rectilinear grid where everything is perfectly square and time ticks by in even intervals and space is all even. Instead, he explored the implications of the idea that space is flexible, is malleable, and that it gets bent by the presence of mass. And you've probably seen some crazy things like this, that space could even bend back on itself. If you saw the movie Interstellar, where you could actually form these wormholes and travel from one place in the universe to another. In other words, space is kind of crazy and different and interesting. So what could possibly be massive enough to cause the universe as a whole to jiggle? And this is an animation of 2 black holes coalescing. The gravity is so strong that it sends waves of shrinking and stretching of space. And I love this. It's vastly exaggerated. So vastly that the distance between us and the nearest star, the size of that jiggle, would be smaller than the width of a human hair. For the nearest star, over 4 light years away. Okay, so ever so slight. Who could think that we'd ever be able to measure such a thing? And yet there it is in those measurements. So how is it measured? An instrument inside this building that has 2 light beams, and I won't go through the details, but when the light beams interfere with each other and the jiggle comes by, it makes the light beams flash. That's the thing. watch for the Nobel Prize. There are two of them. They measured the same thing. We already said the exact same measurement. They're separated by a certain amount of distance. They were actually able, therefore, to localize the direction from which that wave of stretching and shrinking came. And there were 2, maybe 3 detections last year. Then they shut it down, and they just turned it back on again with new improved detectors. So we can look forward in 2017 to more announcements of gravitational waves. There's so much to say about it, but in the spirit of moving on, there are new facilities coming online all over the world. The more facilities we have, the more we can confirm them and get very detailed pinpoint of where in the sky it is. And the search eventually will expand into space as well to use longer baselines and look at different frequency gravitational waves. So big discovery. 2016 was the year. Pop a bottle of champagne when you get home. Yeah. And then the last thing in 2016 that those of you who know me know that I was very saddened, but we turned the Leonard Nimoy Event Horizon purple in honor of the passing of that great astrophysicist Prince. So what else happened in 2015?
Yes, last year we saw the arrival of Juno around the planet Jupiter on July 4th, and it fired its rocket and was captured in a very elliptical orbit that takes it close to Jupiter and far away from Jupiter. And the purpose of this is that it avoids most of the radiation belts, but all the science is done when it's close to Jupiter in what's called perijove. It gets as close as 2,600 miles above the cloud tops of Jupiter. On its first pass in August, it took these wonderful pictures of the northern and southern poles of Jupiter. And also with its infrared camera, it captured the southern aurora, which we've never seen before. It's very energetic, gives off lots of radio waves, and we heard sounds of it. It has a special instrument that can peer down 6 different levels of cloud layers beneath Jupiter, up to about 300 kilometers deep, to show what's going on beneath Jupiter. So the next pass was in October, but there was a computer glitch, so we got no science results. The last close by pass of Juno was perijove 3 on December 11th. And the first images that came in was this one, which is a beautiful picture of the southern hemisphere of Jupiter, showing what is known as this white spot is known as a pearl, or really a cyclone, but it's actually a set of 8. There's a string of pearls in Jupiter's southern hemisphere that are these storms that are located around that latitude, and this is one of them that was captured. Also, this is the view of the northern pole 105 days later, and a comparison of the southern and northern pole, actually no, the south pole, and you can see the changes between perijove 1 and perijove 3 on the right. Very detailed image of the pearl and in the wake it leaves in Jupiter's atmosphere as wriggly clouds. And here's one of the close-up shots of Jupiter as it passed about, I think it was about 4,000 miles. This image was, so this is one of the first close-up images that we've seen. And you can see the difference in detail. On the left is a little bit, an image that's taken a bit farther away, and has Jupiter, has the probe got close to Jupiter's clouds. You can see a lot of detail in the clouds. The next perijove pass, this is just a image of one that Juno Cam took about 9,000 kilometers away. Next one is February 5th. So we'll look forward to more pictures from Juno.
Moving on, in Mars, we had some news stories from Mars, and one of them was, well, this actually happened on Earth, but they grew vegetables in Mars soil. And it turns out that they were edible. Well, mostly. The root vegetables, marginally so. So of course we had to add that in there. It was grown as potatoes, so I'm not so sure those potatoes would have been all that edible. Another thing that happened is Curiosity was given the ability to choose its own laser targets. So If you're on Mars, watch out. If you see Curiosity, it might shoot you with its laser. Actually, what the laser does is it vaporizes rock, and it can measure what the rock is made out of with a spectrometer. It can look at the glowing gases that come off of it. So a very useful tool because it can measure rocks that are too far away to reach with the drill. You can sample things further away. It's seen some amazing layered terrain in its year's drive. This is Mount Sharp. This is what they were aiming for, the mudstones and sandstones that were laid down over billions of years of Mars history. This is how far Curiosity has traveled. The grayed out section on the top is what it had done previously. The yellow solid line is what it drove this year, and the dotted line is where it will be heading. And you can see it's crossed some interesting terrains. It's crossed a hematite unit, which is sort of a layer that shows that water was there, a clay unit, another very water-altered material. So Curiosity, again, has seen all the chemicals needed for life, has seen that the water was fresh, and furthermore, has seen evidence that that water was chemically reactive. That's some of the new science that was done. They saw boron and other chemicals that would have been reacting in this. That's what you need for life. So very exciting news from Curiosity. The Europeans sent a lander and an orbiter to Mars. The lander didn't fare so well, no signal. Oh, that's unhappy face. If you do get the signal with the trace gas orbiter, though, they were very happy to have that. And even the relay from the ground operations of some of the rovers and things is working. So it's another way to relay signals back to Earth with this satellite. Mars Reconnaissance Orbiter was celebrating its 10th year in orbit, and one of the things it did, orbit around Mars, one of the things it did is image the crash site of that Schiaparelli lander that the Europeans tried to see. And since it had spent its 10th year in orbit, we'll just look at a couple of pretty pictures from Mars Reconnaissance Orbiter. I really encourage you to go online and search for those, because it's mind-blowing, the sort of imagery we're getting from Mars. It's just gorgeous. Makes some beautiful desktop backgrounds on your computers. Curiosity is still on Mars, of course. This is not on Mars. This is at JPL. I happened to go for a visit and took a look at Curiosity. The other thing I saw is the Mars 2020 rover. It's in all those boxes, ready for assembly. So pretty soon this clean room will be filled with the new rover being put together. Here's Curiosity again with its drill. And it had a drill anomaly where they're having some trouble getting the arm into the right spot. But it is back moving now. The drill's still having some issues, but Curiosity itself is back doing science and cruising across Mars. One of the new things on Mars is actually we're seeing these things called spiders. And these are sort of...
Spiderwebs.
Yes, well done. You want a prize, come down at the break. And this is sort of a proto-spider. We see these bigger things called spider webs,
I just like proto-spider.
Proto-spider, because these are the bigger ones we see. The spiders on Mars are much larger than these. We think of about a few thousand years, or maybe 10,000 years of development on these. They might turn into the other ones we see. The cool thing about them, you can see plumes come out of the center of these. The carbon dioxide ice, we believe, starts to sublime down in there and creates pressure, and when it can vent out, it can shoot out and create a plume that leaves behind dust, as you can see, that gets blown away. So these are very interesting, active features on Mars. Mars is not a dead location. So, of course, spiders on Mars, and we had to honor David Bowie as well, of course. So, and
Okay, so also we saw a steady stream of data from the New Horizons spacecraft, which flew by Pluto back in 2015. It actually downloaded about 6 gigs of data over the course of several months. And we found that, here's our best picture of before the flyby of Pluto from HST. And then it was instantly transformed to this, showing Pluto in incredible detail in just a few hours of the flyby of the New Horizons. We learned that Pluto has a varied terrain with different types of geology based on ices of nitrogen, methane, and carbon monoxide as created areas here, and cellular structures of nitrogen ices. It also showed us some of its other moons, which are very tiny compared to its main moon called Charon. It also gave us a glimpse of its atmosphere too, and perhaps some hints of clouds in its atmosphere circled right there. Its atmosphere, some of it's blown off and carries away some of those that brown material, which is called tholin, and coats the northern moon, actually the Charon, the northern pole, with the same color. It's kind of like spray painting it. So we also see a large canyon on the moon of Charon. So this that's that. Also, it was noticed that the heart always faces away from the moon Charon, as both of them orbit each other. Both Charon and Pluto are tidally locked. And it's believed that the heart may be a little bit heavier, and here's a closer look at it. And perhaps beneath there, the heaviness is due to maybe an ocean of liquid water. So that's kind of interesting. Now, the next step for New Horizons, as it's already gone past Pluto, is to travel 1 billion miles away from Pluto and visit its next target, which is this Kuiper Belt object, KBO, 2014, and it's a reddish object, roughly about 20 to 30 miles across, and its arrival date is January 1st, 2019, so please mark that down on your calendars.
We will probably have an event.
All right.
Excellent. Of course, the exoplanet discoveries continued in 2016. There were a whole heck of a lot of exoplanets in our list. This is a great little poster you can find, of course. One of the big announcements was that there is an exoplanet around the nearest star to us, Proxima Centauri, part of the, Tony, what is they calling this star now? The
Regal Centaurus.
Regal Centaurus. I still call it Alpha Centauri A and B, but
No, only the International Astronomical Unit calls it Regal Centaurus.
exactly, that's what they're asking us to call it. But the nearest star to us, Proxima Centauri, actually has a planet that is probably one of the most Earth-like planets out there. Its mass is only 1.27 Earth masses. It does orbit its star every 11 days. Now, you might think that would make it super hot, but no, it's a very faint red star that is only 0.1, about 12% of the sun's mass. So it's faint, it's cool. So this planet actually could have liquid water around it. A star that's only 4 light years away from us could have a planet with liquid water. So amazing discovery. This is the chart of total confirmed planets. As of October, it was 3396. It's 3439 right now, something like that. The new number should be downstairs. Of course, I should know that. I'm embarrassed. But anyway, you can see how many were discovered in 2016. It was the most number of exoplanets discovered yet. So far, the vast majority of them are a little bit smaller than Neptune. They're between 2 and 3 times the size of the Earth about. That's the most common planet. Earth-like planets around sun-like stars seem to have a frequency in our galaxy of about 5 to 6%, according to the papers, which is astounding. So you pick out 20 Earth-like or 20 sun-like stars in our galaxy. One of those should have a planet in the habitable zone that's about the size of Earth. So this is the sort of discoveries we're finding with the amazing exoplanet data. So we're, of course, looking for these planets in the habitable zone, like I was saying. Habitable zone is that range where water would be liquid. Those are the important ones. This is potentially the most habitable ones here. And notice Proxima Cb has a habitability index, or Earth similarity index, according to the researchers on Puerto Rico, actually, of 0.87. Not sure how Earth-like that might be, but seems pretty good to me. And they're scattered throughout the entire sky. The Kepler Space Telescope looked in that one area with all those yellow circles on top of it, but the yellow circles are all potentially habitable planets scattered throughout the sky. So there are a lot of them out there. It's very cool. Coming in the future, looking forward into 2017, we're going to launch TESS. It's another mission that measures planets a lot like Kepler did. It looks for transits, the planet passing in front of its star. Where Kepler stared off in that yellow cone in one area, TESS is looking in a smaller area closer to our sun. So it's going to look at much, much brighter stars, whereas Kepler looked at fainter ones. But it's going to increase the number of stars hugely. It's pre-selecting 200,000, and it'll look at about 20 million stars in total. So TESS will find potentially a huge number of planets. It's very, very exciting.
Also, in this past year, I guess we should say, following up from Pluto, the world of icy bodies, small icy things that you wouldn't think are potentially habitable because they just look like they're hunks of ice and nothing should be going on. Well, there are several moons in the outer solar system around Jupiter and Saturn that actually could potentially be habitable, and there's some new discoveries about them. We, of course, studying them is an ongoing concern because we would like to know about them. There are missions planned to go visit Europa in particular. These are the pictures, not to scale. These are what they are to scale compared to Earth. Europa is a moon around Jupiter, and Titan and Enceladus are moons around Saturn. And all 3 of them are likely to have liquid oceans inside, which is interesting because, again, with liquid water being this very essential ingredient for life, then perhaps there could be something inside of them. So if we want to learn more, we need to find out what's going on inside those oceans inside. Well, happily, Enceladus lets us get a glimpse of what's going on inside, because Enceladus, and those cracks on the bottom of it, have geysers or vents from the interior of the liquid that's now being evaporated out, that may be able to tell us what's happening inside. And in fact, the Cassini mission has flown through those vents and taken samples and studied what the materials are. And this year, some of the big discoveries or discussions and what people are working on is trying to understand the dynamics of it. How much water is there? Does it make sense that they should continually vent the way they do instead of closing up the cracks and opening up the cracks? Enceladus, like a lot of these moons, are pulled on by the gravity of Saturn that causes it to stretch and open and close. You'd think it would close those vents, and yet it continuously vents. So it's kind of an interesting amount of work. People are refining the picture of how that works better and better. There are the cracks out of which the vents come. So kind of interesting that there are so many cracks instead of just like a geyser here or there like you have on Earth. There's Old Faithful, but these are huge cracks covering the southern hemisphere. And so obviously we want to understand the mechanism and understand what's going on inside the fluid that's beneath the surface. Jupiter's moon, Europa, is also another candidate for being a habitable world with a vast ocean inside. But the trouble there is, how do you drill through all of that ice to get to the ocean? Enceladus's vents are very clearly visible, but this past year, Hubble Space Telescope observations supported the idea that there are actually vents coming out of Europa as well. So a mission that flies through those vents could maybe study what the nature of the liquid inside of Europa is. Is it the right mix of chemicals and conditions that could be supporting life? So these are just the observations. It shows you different dates that they were seen and then not seen, so it's not like Enceladus with the ongoing vents. And as you can tell, these are very low signal to noise. I mean, this is very borderline. But it matches very well some other observations taken with a completely different technique a couple of years ago, with the same in the same location and about the same amount of vapor coming off. So it's very suggestive that we may actually be able to visit Europa and not have to drop. I mean, believe it or not, there are people saying, let's nuke the thing so we can melt the ice and go find out what's inside. And maybe not so good for the life inside. So this would be very nice if some of that fluid came out and let us explore it without having to bomb a big hole in the world. Then the third of the icy moons I wanted to just mention is Titan, just because Titan's so magnificent. Not only does it have a liquid ocean inside, but it is covered with these these hydrocarbon clouds and nitrogen. The underneath the opaque atmosphere, Titan is a world very much like our own, surprisingly like our own. These are images that show the Lake District in the north, near the North Pole. I like that idea, vacation in the Lake District. There are mountains, and the lakes have river sort of tributaries and canyons. And one of the big discoveries this year is that those canyons are also filled with liquid methane. So, there's a whole hydrological cycle. There are clouds of methane. Some of the details are not clear, the way these clouds form, or there's some, it's not quite the way they do it on Earth, and in fact there were some challenges trying to understand it. So every time we study a new world, we find new processes, new mechanisms for the way planets can work that help us understand our own planet. I'm sure our speaker is going to talk about that later. Sure enough, Titan has this amazing surface, very, very cold, but liquid because it's these liquid hydrocarbons. And it rains and collects into pools, evaporates, and rains again, just like it does on Earth. Who'd have thunk this crazy little icy moon out there would have such an interesting weather cycle and could be a very, very interesting target for life. I think this one is for you, Patrick?
Yes. So this is a Dawn spacecraft, and it gave us detailed views of two of the largest objects in the asteroid belt, Vesta and Ceres. And we can see as it got approached these two objects, first Vesta in 2011, You can see Vesta is a cratered world, and Ceres is also a cratered world, but a little bit rounder. This is Vesta, with a heavily cratered world with a solid kind of crust with iron in the center. And this is a southern pole view. So that was 2011. The Dawn spacecraft took a 4-year trek to Ceres and spent most of its time in 2015 to 2016 approaching the dwarf planet Ceres. And one of the interesting features is, of course, these two bright spots in this 52-mile crater called Occulta. You can see detailed images here as it got really close as 270 miles above its surface on its primary mapping mission. These white spots are believed to be brought up by briny, salty liquids, and then they've deposited these brilliant, highly reflective salts in the center of the crater. Here's a colored view of it, composite color. Also on the Ceres is another interesting feature, and it may look like a depression, but this is actually a volcano, a cryovolcano, which is just basically upwelled from maybe water ice, and then just kind of frozen on the outside, just kind of like a pimple on Ceres. It's about 16,000 feet tall, and it's very tall for a mountain that size on a world that's only about less than 600 miles across. The Dawn spacecraft also measured the amount of hydrogen that's present, which gives you an indication of how much water there is. On the left, you see a little bit of water on Vesta. Vesta has about 100 times less water, kind of watery hydrogen kind of compounds than Ceres. And Ceres, you can see a lot of it is concentrated on the poles where it's kind of bluish, and a little bit around the equator. It's estimated that Ceres has about 20% of water ice mixed in with its rocks. So it's actually a really interesting watery world compared to a traditional asteroid type of body like Vesta.
And we will have a mission wrap-up, a speaker from Vesta. We're having a speaker come from Vesta. From the Dawn mission in June. So mark your calendars. The June All Space Considered, we have a guest who will be summarizing the Dawn mission.
Hey. Back in 2014, the Rosetta spacecraft reached comet 67P. Your last chance. There you go. And also that year set a lander called Philae onto the surface of the comet. We got close-up images, things like that. Now, a mystery happened. We didn't know where the comet, where on the comet Philae landed, and also Philae apparently tipped over, and we only got a few days worth of data from it, and then it kind of disappeared. So a big mystery solved in 2015 in the summer. Well, not a mystery so much, but actually throughout the end of 2015 and this year, Rosetta got beautiful images of the comet's nucleus as it approached the sun in 2014, was closest to the sun, and then departed away from the sun this year. So we, for the first time, got to see an activity cycle on a comet. So here's the...
so just the thing about Philae. Philae was lost in 2015, but there was a potential that we saw for a couple of days, about a week in the July, that we might have gotten a signal from it, and we honored it with this.
Alive! It's alive! It's alive!
So those were the controllers at JPL. Very happy, but then it did not come back to life, sad to say, poor little Philae. But this is a picture of it in its final resting place.
In this year, Rosetta itself was sent to impact kind of gently, but nevertheless decisively on the comet surface. But before it did, it actually did pick up an image of Philae, so at last we saw it stuck sort of in a crevasse. Yeah. And as it approached the surface, it got absolutely magnificent views of its strange low gravity surface, unique to comets, I guess. And finally sent a picture showing things just a few millimeters across before it hit the surface itself. And to to come, the best images that the Rosetta took are still being released. They were received over a year ago, but there's an embargo on making them public. So after a year, they're put on the web. So you can search these out, and absolutely magnificent images. This is from, I believe, November last year. Now, coming up, we have the space station, and what did it do in 2016? Well, probably the most famous event, or most popular event, was Scott Kelly's nearly year-long stay. So from 2015 to the middle of 2016, he spent nearly a year in space, mainly so we can learn more about what happens to the human body in low gravity for long periods of time. We need to know this stuff if we really are going to send people to other planets on very long missions. The space station completed 100,000 orbits. And the Bigelow Company of Nevada added a commercially built and purchased by NASA module that, after some trouble, finally successfully inflated. And this is kind of a deployable structure, and maybe we'll see more of these in the future. All right, so SpaceX had a number of successful launches, landings, some not successful, some successful, but they did finally land their booster on a drone ship successfully. Unfortunately, in September, using a new type of compressed or low pressure, low temperature oxygen system, their booster exploded and destroyed a $250 million satellite, and they've been grounded until just actually a couple days ago. Elon Musk revealed his main plan for SpaceX, which he hopes will be colonization of Mars. And so back in August in Mexico at a space conference, he unveiled these very ambitious plans. Blue Origin, another spacecraft company which is working right now on suborbital spacecraft, continued a series of tests where they were able to launch and then land a booster and then separately land the capsule. There was another test where they, if we can go on to the next, where they tested the escape system. This blasted off from the booster, but the booster wasn't destroyed or anything. It successfully landed, and the capsule safely came to Earth. So if you get a ride on one of these things sometimes, in the next couple of years, you'll be in good hands. Cygnus, who is one of the suppliers of the International Space Station, has had to use Atlas rockets to get their capsule up because of an explosion back in 2014, but their own rocket, the Antares, went back into action and started delivering things to the space station again. Virgin Galactic, recovering from a 2014 accident, began flying a new Spaceship Two called Unity, and so far it's undergone a couple glide tests, and these will continue. Falcon Heavy, which is SpaceX's giant rocket, it's like 3 Falcon 9s put together, is scheduled to launch around the middle, maybe late part of 2017, and Elon Musk snuck this sort of a teaser picture of the actual booster, and this is what it will look like when it is launched.
Is that going from Canaveral or from out here?
It'll be Cape Canaveral. Yeah. And then Blue Origin in 2017 should actually be the first commercial company to put people in space. They plan to do suborbital flights with test crews sometimes late this year. And then that'll pave the way for paying customers who just want a 4-minute ride into space. Now, Google, at the end of this year, announced several contestants now have secured flights for 2017 to land BattleBots. No, to land both landers and rovers on the moon. So these are all built by private commercial companies, and And so we actually should see an exciting return to the moon. These may be establishing things that people like universities could buy to send equipment in much cheaper than in the past. And SpaceX is also working on a crew orbital spacecraft. It should have its first uncrewed flight by the end of the year.
Okay, China is gearing up for another mission to the moon this year. And we're going to go ahead and roll video. This is the Chang'e 5 mission, which is going to land a lander on the moon, scoop up material up to 2 kilograms, take off and send it back, the sample back to China for analysis. And we don't have any details of when or where it's going to land on the moon, but it will be announced when we see it.
And then finally, looking farther into the future, but something that happened this past year, was the president published an editorial about how we will be going to Mars in 20 years as a joint effort between NASA and private sector. But we just like this CNN article because it was very careful to let us know that he's the president of the United States, just in case you didn't know. And then finally, Cassini, everybody's favorite. Cassini, because Cassini was launched in 1997, arrived in Saturn at 2004, and has had an amazing mission. I'm not going to go through all of it now. We're going to absolutely have a dedicated talk all about Cassini because it's an amazing mission. But the main thing that's coming in 2017, and I think you know where this is headed, is it's the end of the mission in 2017 in September. It will decisively crash into Saturn. So it's going through a series of maneuvers to change its orbit and go through the ring plane. They wanted to save this to the end because you don't want to go smashing through the rings early in the mission. You want to make sure the spacecraft is fine. So it's doing changed its orbit to go outside the main ring belt, and then in April it will change its orbit again to pass between the main rings and the planet itself. It has gone through one of those passages now, I think maybe even two. Five, good heavens. And taken these amazing images of the North Pole. So what it might be like if you're flying along with it, in that. And then, I know, that's very fun. And here's showing the orbits as they go in. At the very end, kaboom. We have a special surprise guest, somewhat last minute, but thrilled to have him join us. And that is Dave Duty. Well, come on up, Dave, from JPL, Jet Propulsion Lab. Dave has joined us before, and I'm going to put him on the spot right now again and ask him to join us again and tell us all about the Cassini mission when the mission is over.
Excellent.
And we can, okay, we're on. David Grinspoon, if you were wondering about that picture we doctored of you in the beginning, consider yourself fortunate because when Dave was here before, we did this to him. But it was because we did that to him. Okay, there we go. I had to put that in there. I'm sorry, Dave. See, this will teach you to come to All Space Consider.
Well, that'll guarantee that my boring chart won't put you to sleep. So this is what we're doing right now. On next Monday, we do our number 6 flyby, very close in to the rings. Now, on my chart, I've got time across the bottom. Here's February, there's January, going out to September of this year when we end it all. But I'll be looking for a job. And then along this axis is space. Down in here, this is Saturn. We've got it stretched out just to show you the distance from Saturn. Here's the upper atmosphere of Saturn is right here. And then we've got the inner D ring, and then the C ring, the B ring, the A ring, and see that little strand? You know that's the F ring. And the F ring is that amazing narrow ring that's twisted and braided because of all the interactions with a couple of moons that orbit Saturn, Prometheus and Pandora, but also because of other things that crash into it all the time. But anyway, these dots up here are my story. Those represent the close passage as Cassini comes hauling in from way out and flies closest to Saturn through that ring plane and then climbs on back out. Think of it as a roller coaster, up a 1.5 million kilometers up to the high point, slowing down, click, 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 to about 9,000 kilometers per hour relative to Saturn. And then by the time we come in past the rings, we're doing 76,000 kilometers per hour, that fast roller coaster. And then so each of these blue dots are the ones that we have done, the 5 there, and then the 6th one is next Monday. And this dotted line up here is the JE ring. What would JE stand for? Janus and Epimetheus. They're 2 moons that orbit at that distance.
Who was going to guess
And
that?
they contribute dust. And so we're measuring the dust up in there. These big numbers down here are the command sequences, the thousands of commands that we load on board that take it through 10 weeks. So 10 weeks there. This is a 6-week one. And we do this last F-ring passage, and then we fly by Titan, April 22nd, and that gives us a boost. The astrodynamicists are just magical. They planned this so that Titan flyby makes us jump all the way down to in between the rings and atmosphere. And we've got just a few thousand kilometers to play with. We get even farther down, August, September, and then there's one final Titan flyby that pushes the spacecraft's periaps so close that we plunge. And that's the Friday, September 15th at 3 a.m. You want to do something here?
Will there be
And
something to see?
There will be so many things to see.
Then we will do something here. Friday
there-
what? What day?
Early in the
Friday?
morning, Friday, September the 15th,
That's
which leaves
sweet
us
thing.
the whole weekend to party and celebrate for the rest of it. So that's my story, and I'm sticking to it. Thank you.
So our last looking back and looking forward is from our favorite planet, Earth, which had, yay! So I think everybody knows by now it was the hottest year. We were on track all year to be the hottest year on record, and indeed we are. Here's this nice little graph that just shows what the other peak in 1998, but in fact we edged it out as the hottest year. What's kind of interesting, of course, are the in-between times before 1998 and what it's been since. I have a feeling we'll talk a little bit more about that later. And also significant this year was the extraordinary Arctic melting, very unusual. There were times this past fall when it was actually melting when it should have been freezing as we went into winter. So it's had similar effects in Antarctica.
Yes, and scientists have been monitoring a large rift in this area, which is the Larsen Sea ice shelf, the 4th largest in Antarctica. You can see how big it is. It's about 300 feet across, and it goes down as deep as 1/3 of a mile. If we go to the next slide, this is kind of the measurement that they've been making. And since March, this whole rift or crack in the ice is about 70 miles long. Now, we just got an update, and we'll go to the next slide, that the crack has extended much further now and is now only about a hair short, 12 miles to this edge here, which means that this ice shelf, which is about the size of Delaware, is going to be separating from the Larsen Sea main ice shelf and floating as a gigantic iceberg in the Southern Ocean. And there's an aerial view of it taken in November 10th.
So as we often do, we like to, after bad news, have furry animals. So this was this month's favorite. We just thought between the child in the lion costume and the lion, that was just, for those of you who have never been to All Space Considered, you might think this is quite strange because it actually looks like the lion's about to have the child for lunch, but it's just a little furry animal break.
What is that, Ari?
To make us feel good.
It's a big U.
Yeah. Good thing the glass is there, yeah. So But our final story is California's story, this video.
Right, and this is all the drought maps since beginning of last year. And you see that not much happens during July, August. If you look at the northern part is faring better because of what we had. We had some El Nino event, but it didn't really affect much of California, the central and southern region. And along the summer, of course, we don't have any rain, so nothing changes. And then you notice we've been getting a little bit more rain, so there's been significant reduction in the amount of drought. And there's the one from January 3rd, which we're getting a little bit better. Please contrast that with one of the worst times back in 2014. So this is definitely something to at least. We're still in a drought, but we're in a much better place, and we hope for more rain to come in the next few months.
So, and then the most important thing in the universe in 2016.
Sure as God made green apples, someday the Chicago Cubs are going to be in the World Series.
Yay! So, Chicago, she got it. But get a prize anyway. So, I know, any Cubs fans here? Yeah. Yay, thank you. Me too.